Let's
All
see.
right. Let's have Gary go ahead and take over and give us a presentation on LINQ.
Great, thank you. I'm excited to be presenting tonight. I think looking back at the calendar, I was probably the last in-person speaker who spoke at this user group right before everything shut down for COVID. And so it's been a lot of changes, obviously, in the world. Big change for me. I've changed jobs, and now, as Steve said, I'm a senior engineering manager, which largely means that I spend most of my time not coding. So for me, this is a great, fun experience because I get to do the prep, write some code while I'm prepping, and have some excitement. Kind of getting back nitty gritty. I'm able to spend about 25 or 30% of my time coding in the job I have now. And even then, that's a lot. A lot of that is infrastructure as code, and not as much C# as I'd really like. So tonight's talk is basically LINQ improvements you might have missed. A better title may have been LINQ lessons, and there's a link on YouTube, or not on YouTube, on GitHub, and that's the title of the repository on GitHub. Is LINQ lessons. So we're going to actually do two things as we go through a bunch of sample code tonight. The first is we're going to look at some lessons that I've learned, some things that I've noticed as I've had an opportunity to do some mentoring, do a lot of code reviews. Currently, I'm working with a team who not everybody has got a strong .NET background. That sometimes we're coming from JavaScript. I've worked with some people who are coming from Python, and so they things don't work the way that they sometimes expect. And so there's a lot of things that I've seen in LINQ over the years, and I've kind of collected those as basically lessons. In addition, we'll take a look at some of the improvements that have happened in LINQ. Primarily improvements that happened when .NET 6 was released. And we'll talk a little bit about the improvements in .NET 7, but primarily the .NET 7 improvements to LINQ are almost entirely on the performance side. And I don't think that as we go through the talk tonight, we'll look a little bit at benchmarking a couple of things just for the interest, the exercise of benchmarking things, but I've not taken the time to build out benchmarks for everything and then compare the benchmarks to the different runtimes, things like that. That'll be an exercise for the viewer for later. So just to be clear, can I get a couple of people on camera? Can I get a thumbs up that you can see the screen, see the code, and see the link to the GitHub? Excellent, fantastic. So tonight we're going to be using I'm going to be using LINQPad. And if you're not familiar with LINQPad, it is a fantastic little coding scratch pad. There are free, dev, pro, and premium versions. I think the current pricing is $115 for the premium version, which gets you licensed for 3 computers and 3 VMs. And I get nothing for talking about LINQPad. I'm not associated with LINQPad. It's just probably my favorite, one of my favorite outside of actually the actual IDEs, one of my favorite tools. I love the ability to connect to data sources and do some code experimentation in LINQPad. And even more, I love that we can see some of what's going on underneath the covers of the compiler and how things are evaluated. And then it's got this fantastic dump extension, which will display collections in a way that makes it really easy to kind of see what's going on. So we're going to use that tonight. I need to see if I can move these controls because the controls are in the way of my screen. Or maybe I'll just that didn't work like I wanted it to. Okay, so let's start with a couple of lessons. And one of the things that you'll notice is all the lessons are numbered. And so the numbers that start with 1 are primarily code review lessons, things that I've just kind of learned over the years, things that I see quite frequently, and things that we want to talk about. And then anything that starts with a 2 or higher is going to be something that's come from the newer versions of LINQ. So when it comes to reviewing code, one of the things that I see quite frequently in LINQ is is leaving an extraneous where filter. And so I've got a little code here. I've got a simple record for employee, a simple kind of a mock repo that gives me a collection, a list of employees, but it returns it as an IEnumerable. And I just want to get the first employee where the ID is 42. And if you're like me, very often you'll start coding and you think, okay, well, I need from employees, I need the employee where the ID equals 42, and I want the first one. And so you run that code and it works, and you move on, and off you go, you're off to the races. And it's not a huge issue. It's it's most of the most providers will optimize this away, but it's a kind of a long-term code readability issue, in my opinion. And what you find is that a lot of the other LINQ operators allow you to put your filter in the operator. And this was fun when LINQ first came out, because you would find providers that would take the where and the first really literally. It would say, I need employees where ID equals 42. Well, in this case, I only have 1. But if you had something like, I need employees where ID equals Smith, it would take that very literally, and you would get first an evaluation of the collection, sometimes early evaluation, and it would get that whole collection, and then your first would just get the first later. So you would have you could have some performance issues. Most of that has been optimized away by the LINQ providers, but it's still, in my opinion, a kind of a readability issue. It just seems easier to me to read and maintain. I want the first employee where the ID in this case is 23, and voila, we get the same kind of action, same kind of behavior. So that's my first kind of code review suggestion, is to watch for extraneous where clauses. The next is where chains. And so this is going to show off another feature of LINQ, and that is, or not LINQ, LINQPad, and that is that LINQPad includes the Chinook database, which is a kind of an alternative to Northwind. There's a link in the code here. If you go to the GitHub repository that I showed before, the links are all in the code. But so GitHub is just a record store, or not GitHub. Chinook is a record store database. And so we're gonna take a look at where chains here. And again, this is a situation where most of the providers have optimized these away. But you see what we have is code that says, I want the last title with A, but it's chained. So I have albums.where, and I've selected title starts with A, order by A and A title, and then get me the last record. And again, we can move that to, just like we had in the first example, we can do our order by and then put our filter in the last operator. And so I'll run this first. And so see, we get the same results. And LINQPad also has benchmark.net kind of built in as a utility. Now, I don't know whether this is part of the free version or whether it's part of the premium, but in your query, you have an opportunity to do benchmark selected code, and it will add the requirements in order to benchmark your functions. So I've actually taken part of I've taken part of this code up here that dumps the individual record, and I've moved it down into benchmark functions. So we're doing the same selections and just looking at, in this time, just doing a toString. And I'm going to run the code. And when I run, oh, I didn't uncheck the run benchmark. So when I run the code, what you can see happening here in LINQPad is that there's a little bit of warm up, and then it's going to actually start running each function. And as it runs each function, you can watch the operations count go up. And so it's even by default, the way it's set up, it's very smart about starting with, it runs 2 operations, then it runs 4 operations, then it runs 12, and then and on in kind of an exponential fashion until it has kind of a good sense of how long your average min and max time is to run the functions. And you can, again, like I said before, in this case, I've got it set up only to run against the .NET 7.01 runtime, but you can set it up to run against any runtime that you've got on your computer. And so we've run all these operations. We have roughly the same mean, minimum, and max times. I mean, they're really pretty close after 100,000 operations, and that would make sense because in this case, our SQL provider to SQLite is optimizing the query. It is smart enough to tell that, oh, he put where, but then he put last. And I know because the people who write the provider are smart enough to know, well, I can do that. I only need the one. Record coming back. So the LINQ provider will return only the one. It's not forcing a return of the entire enumerable, and then on the .NET side picking the last. So that's where change. Again, in this case, not a huge deal in terms of performance, but it can be depending on your providers. So it's something to watch out for. And again, I just think that it's a little more readable to put those filters in those operators that support it. You'll also notice that in your IDEs, if you've got linters turned on in your IDEs, a lot of these issues will get highlighted by those linters, and it will tell you whether you've got an extraneous where clause, or that there's ways to optimate those queries. Next, this is another thing that we see sometimes.
Gary, there was a
yes.
question in the chat about that last one. Is that the SQL that's generated by the LINQ queries? Was the question.
So in this case, what LINQPad is doing is LINQPad has as a link to SQLite provider, and that provider is what generates the SQL statement. So that is being provided. That's being the SQL statement is being generated by the database provider that LINQ is calling. In the very same way that if I was using Entity Framework, if I have Entity Framework on and I turn logging on in Entity Framework, you can see the SQL that's generated by Entity Framework. It's the exact same idea. And then I guess while I'm on this tab, we're not going to dive into this at all today, but if you're really interested in what's happening under the covers, LINQPad also has essentially disassemblers. I mean, it's intermediate language, so it's available to ILSpy or anything else, but it's built right into the system, and so you can actually get really deep into what's happening under the covers with the functions that you run. Okay. Did that answer your question, Alex? And I see Wayne's got his hands up. Wayne, do you want to go ahead and ask your question? Oh, you got to come off mute. And maybe that's difficult. You're still on mute, so. if you want to, you can type your question into the chat. If it's a really long question, I know that can be difficult, so you can. There we go.
Hey, when you have the two LINQ queries that you're doing the differences on, if you have a unindexed column and you have multiple, thousands of A's, how does those two performance work in terms with relation to each other?
So I'm not necessarily a database performance expert, but my understanding is that the database provider connects to the database engine. So if there are indexes available in the database provider is going to tries to take advantage of those indexes. Right. Some of these, some database providers are richer than others. Obviously, the entity framework, so the connection between C# and entity framework and LINQ is really tight. I mean, not in a tightly coupled way, but that those teams talk and are able to do optimizations that are really pretty efficient. So what I've seen when I've run profilers on some of the projects where I'm using LINQ to do LINQ against a repository that's connected through entity framework to SQL Server, is in those providers. It's been rare in my experience that available indexes have not been used. So, all right. Great. So let's look at double order by. So double order by is a common kind of a common mistake as a beginner. It's just easy to make. Again, not a big deal, but what we've got is I've got a connection to the demo database. I'm going to get my albums in order by artist and order by title, and I said that in a very specific way. So when I order by artist and order by title, what I would expect to see is my first A artist, or my first alphabetical artist, and then all of the albums that match them, but I don't. And that's because the second order by basically cancels out the first order by if I just use the order by operators. So the way to properly chain sorting in LINQ is to, in fact, let's see, actually I'll run both of them, is to use order by and your first lambda, and then use the then by operator, and you can chain multiple then bys. You also have the opportunity to do order by descending and then by descending if you want. But now we'll run both of those. And so this is a very long result list, and I'm not particularly interested in that first result list, but we'll scroll down here to the second. And now, actually, let's do that. We'll collapse that one. And now I have artist ACDC and artist ACDC and artist ACDC. So my sorting is the way I expect it to be. And that's, again, if we look at the SQL in the providers, we should see, actually, let me run it one more time and then we'll look at that, because I believe, yeah, when I did the expansions, it showed the SQL of the expansions on those. So my first one, you can see that it threw away the order by artist. And in the second one, because I used the then by, it orders by artist and then by title. So so kind of what you would expect. Excellent. So this one's a little more obscure, and this is sets to nowhere, and this is starting to get to where we'll start talking about some of the new improvements in .NET 6. So LINQ has set operators. So it has union, it has intersect, it has distinct, and those set operators can be really useful, especially if you come from a SQL world and you're used to thinking in sets. And so what I have here is I have a list that's my first list of employees, and then I've got a second list that's recent employees. And what I expect to do is I want to do a union on those two lists. So I'm going to run this query, and you'll see in the note that it says the union set disappears. So if I look at the results that came back, what I end up with is just the 42, just the 15 employees that are in my first enumerable that come back. It ends in 42. The other set of employees were not, well, they were added to the list, but this function, the set functions, do not work like an add range. They are basically functional. They create, they treat your original sets as immutable and only return what the modified set would be. So if I'll comment this one, we'll uncomment this one, and we'll run this one, and we'll see the result. So in this case, in the first case, I just had employees union and treat it like an add range. Take my first collection and add this other enumerable range to it. In this case, I'm saying I need a new collection, and in that collection, store the result of my first, store the result of unioning that second collection in. So when I run this, I get 42. Now I have 51, 52, 53. So that's what I expect. Now there is obviously you can work around this if you'd like, but it's not what I would recommend. I've found, my experience is, the more you move towards kind of a functional programming paradigm, the more you write functions and do actions that don't mutate the state of existing functions or existing objects, the better off you're in the long run. But you could take your first collection and make it a list. Now, a list is IEnumerable. It also supports iCollection, and like an iCollection, and arrays, it allows add range. So if we run this one, we do have the same result, but it means that my original value of employee to list is now gone. For the duration, for the scope of that variable, it holds all of these and not just the original list. There's trade-offs to any of these. As any good architect or system designer will tell you, there's always a trade-off to everything. But my preference is to use this method, to use unions and return a new set. And part of that is because of an example shown here. So if I want to use union on primitive sets or intersect or distinct, any of these set operators, if I'm operating on primitive types, then those primitive types have a built-in equality operator, and they work great. They work kind of exactly how you would expect it. I get the right union between these two lists. So I would expect union to merge these two lists and only show me individual values from each list, not include all the duplicates. That works great. I've got exactly what I expect. The problem is when I go to use union on collections of complex types, I may run into a problem. So when I run this, you'll see that this time, it recognized that I had my comparator. I got myself ahead of myself. So in order for this to work, if I comment out this code for a second, run it again. There we go. So this time in my employee repo, somebody hasn't updated the get recent employees for a while. So I have employee 41 and 42, Martin and Joshua, show up twice. They show up in the existing employees and my get recent employees. When I union those, because by default, classes, custom classes and records don't have a comparer built in, then the union has no way to know whether there's duplicates. And so when you do union on complex types, if there are duplicates in your set, you will get those duplicates included. If you're trying to do an intersect or a distinct by, you'll get behavior that may not make sense. So the way to get around that is, obviously, I'm going to comment back in the comparer. And once I have a comparer associated with my class, I can run that, and I think I'm seeing a bit of unexpected behavior, and this might be a last minute change. Originally, my employee was a class and not a record. And I think the fact that I've got it as a record and then built a comparer that's attached to that employee, I'm getting the right behavior without having to pass in the actual comparer. But when I was doing my original versions to compare classes, I was having to use, yeah, that's the problem of doing late changes. When I did my original versions, I was having to do, with the class, I was having to use this overload of union that allows me to pass in a comparer. So that's something to be aware of on all of the set operators. Okay. Now, you know, I know we're all just shaking with excitement. This will be our first example that talks about new functions, new extensions that are built into .NET 6 that expanded what's available with LINQ. And in this case, we have, similar to what was running in the last one, I have the same sets. So I have my get employees, and then I have get recent employees, and it has a couple of duplicates. Because I'm passing in a comparer, that union with comparer works. I don't get the duplicates in my union. But they've added now, they've added function or extensions called set that are set by. So union by, intersect by, and we'll go through examples for each of these. So union by allows you, rather than to need a complex comparer, if I know, for instance, that the only that ID is my unique identifier, and I can say if the ID is duplicated in the two sets to ignore that, then I can pass a simple lambda, a key selector, into my union by, and I get the expected behavior. And so for each of these similar extensions, we can do similar actions. We can pass in a essentially what's called a key selector. So for intersect by, my key selector says I'm going to pass in emp and emp, and I'm going to run my intersect by, and in this case, I get all from the first set where the comparison intersects the second set. And one thing to note on all of the set by operators is that order matters. Priority is given to the first set. So if something exists in the first set or doesn't exist in the first set, depending on which of the operators you're using, it's that first set that takes priorities. If you reverse the sets, you may get different behavior in exactly the same way that you would if you were working in SQL and you had you change the order of the tables, but leave the left join in those queries. So again, it's kind of like SQL in general. So distinct by, it differentiates on the key selector and returns the first instance of each site. So distinct by, again, gives preference because I'm passing in employees, gives preference to distincts in that list, and except by gets all the lists all from the first set, except those whose key is in the second set, the way that I've written this out. So so in this case, it gets all those in the first set, but it excludes those two duplicates that were in the second set, and it excludes anything that was in the second set that's not in the first set. And so these can be fun to play with. They can be a little bit difficult to wrap your head around. So I would suggest that if you just do a search for set by, or a search for any of the individual extensions, distinct by, union by, then you can find the Microsoft documentation on these features. All right. Back to a little code review change, and this is probably one of the more common, and that is in my I guess weakly held opinion, I guess. So I'm willing to be convinced otherwise in just about any situation by a strong argument, but I don't believe that we should use exceptions for control flow. And I see this really commonly in functions that use LINQ and rely on first. So for instance, as a simple example, imagine we have a login screen, and so I'm passing in, I'm doing my login, and I'm passing in a couple of IDs to try and log somebody in. And when I do that, I've got Adam Smith, or the login for A Smith, that exists in my set down here. And so I processed through my exceptional login. I've got everything wrapped in a try catch. I find in my repo that first login, and I process the login. When I pass in a different email, that email doesn't exist in the set. And so in that case, I throw an exception. And my question, when I'm doing code reviews about this kind of behavior, my question is this really exceptional behavior? Because if it is, then by all means, use a try catch. But it seems to me that somebody mistyping their password, or even somebody trying to attempt a login when we don't want to allow that login, when their rights have been turned off, or they don't exist in the system, that's not a exceptional flow. That's an expected flow. That's something that we would normally want to see. So in this case, I will comment these out, and we have a different function. We have a flow-based login. And when we look at the flow-based login, you'll see, again, the recommendation, don't use flow for exceptions for flow control. So in this case, we use first or default. And this is a really common pattern. We see do first or default on the login, and then we do a check. If the value that came back from our query is not null, then do something. Or sometimes you'll see it reversed. If it's null, then that's a guard condition, and we exit out early or do something, something that's appropriate for this flow in the system, but it's not really an exception. It's something that we expect. In this case, in a login example, we expect some people to have an invalid login attempt. And so we check for whether the object is null, and then if it is null, then we process that. We may have a login, or we may have a log action or something. We may have a function that does, if there's so many login attempts with the same invalid email, we alert or whatever, but it's an expected flow. So we do that without using exceptions. We reserve our exceptions for truly exceptional flows. And that's kind of been, it's a long pattern, and you'll see this a lot in code, that you'll see you'll see this same pattern of if something returned is null or is not null, you'll see instead of using the is not syntax, you'll see it using this the exclamation point equals for not equals null or whatever. All that's perfectly valid. But our next .NET 7 or .NET 6 improvement to LINQ is we can now return we can now return default objects for first or default or singular default. So in this case, this is the old style. We return an object. The object is not found, oh, that was supposed to be a single. Sorry, this should be single. Updates to the code will be posted to GitHub at the end of the talk. So these both return null. If we have a call to single, I have to comment these out. If we have a call to single and there's more than one single, we get an exception. And if I had this wrapped in an exception handler, we'd see that exception handler flow. And then again, we're back to, is that something that should be exceptional or not? What was added in .NET 6 is the ability to return a default value, a custom default value for first or default or singular default. And so it's important to note that this still doesn't eliminate the need for checking the values that are coming back, but it makes the behavior of LINQ match the direction that lots of other areas in C# are going, where we talk about nullable types and null checking at compile time. And so this gives us the opportunity to write LINQ queries that we know will never return a null object. That if I run these, then what I'm expecting is a default object when I run first or default. But you should note that single will still return an exception if I return multiple, even if I'm expecting a if I return multiple. If it has none, so if I do Stefan, and there's no Stephans in my data set, then it returns my default. But if I'm calling singular default, and I think that was what, David? I think there's multiple Davids in my system, and so that's why I get the exception on singular default. So in this case, I didn't go through and code for the next feature in .NET 7 or .NET 6 for LINQ. I didn't, and I keep saying .NET 7 because .NET 7 has been out for a little while, but so forgive me. I'm generally talking about all these features were added in .NET 6, but this is a big deal to me. One of the most common questions when we have large sets is, how do I chunk this out in order to do some kind of pagination? And in the old days, you would have to write your own extension method to do chunks. And so you can find this again on the GitHub. There's a couple of questions that are common questions. This answer is actually a great answer, and it's an answer that I have had bookmarked for years about how to do this and write my own enumerable if I need to do custom chunks. What was added in the newer version of LINQ is a chunk extension that simply takes an int for chunk size. And so we run that, and in this case, I have now an IEnumerable in chunks of individual chunks of the individual elements. So I have 3 sets of 5 employees. So if I want to do pagination, I can do that much easier with the built-in chunk function. And to see, And as Court says, that's cool. I'm telling you what, that's probably my favorite part of this talk is chunks. Because chunks are a big deal. So here we're going to do it. We're going to do it against SQL. And so this is again my album collection over in my sample database. And this time I'm not going to dump every chunk. I'm just going to dump the count of each dump. So this time I've got chunks of 25. I have all of these sets. I have all these sets that are 25 albums in each set, and with a last set of 22. And I just wanted to show you this is something to be aware of. Your providers require casting, first of all, up here to an enumerable type. So most database providers, I can't just say albums.chunk. This requires because a DB set, for instance, a DB set is not IEnumerable. So I have to have something that supports the IEnumerable interface. The other thing to note is when this returned, I did albums as enumerable. When this evaluates, notice my SQL is the entire set of albums. So all 300 some albums came back to my .NET code. My .NET code then took that evaluated set that exists in memory and chunked that out. So this can be a big deal. You cannot just naively say, oh, chunk is a great feature. I'm going to now chunk, every invoice in my commercial billing system that's been in existence since it was a Foxborough system, and we've in the late 80s, and we've migrated the data multiple times so I can look up invoices forever. Your system will die if you do that. So if you do need to chunk large data sets, you are still back at figuring out how to do that chunking on the server side, and particularly in the SQL side. So one of the most common ways to do that is to use offset and fetch. And so in the code, and so you can also Google, if you Google offset fetch, you'll get a ton of links. But one of the best links is the SQL Server tutorial on offset and fetch. So yes, Wayne.
Can you post that to the chat right now, that link?
Yes.
Thank you.
I think I can. All right, so we're getting close. We're going to wrap up a couple of things. So a couple of other things that were added is enumerables now support element at, and by running element at, we also support I forget the name of this operator, but we're able to do basically count backwards from the end. So I'm able to say, give me the element at position 1 or position 0. And get the element from my enumerable. I'm also able to say get element at 1 and I don't know if it's a negation operator, what it's called, but that will get me the last. Now we have to remember our enumerables are indexed from 0 to the end, and so if I try to count backwards and I put 0, I'm going to get an error because I'm out of range. So I have to remember that when I'm counting backwards, I have to start at 1 when I count backwards. But that's really cool, employee repo. And then if we do same kind of idea, we can do element at on our albums, and then we can look at the SQL that gets generated for these. And again, just a note, this is evaluating the full collection because these are deferred, but each time I run this, it is running the whole collection order by, and then it's getting the last album from the evaluated enumerated collection in memory. So again, if you're doing 20 years of invoices, you likely want to look at a different option than using element at. And in the same way that that element at allows those indexes. The take extension in LINQ now supports the range structure. So I can do for a simple and take supported ranges for simple arrays and collections for a while, but it wasn't supported until .NET 6 for just enumerables. So .NET 6 added that in the added the range support in the enumerables. And you can do all kinds of great combinations for this, but this gets me from my third employee to my fourth employee from the end by using the range syntax. Now, it is important to note that while take int and skip int are extensions, are functional complements. So take gets the group, skip ignores the group. There is no skip range overload. And I did check today the .NET 8 preview. So I can't do skip the middle of my collection. If I want to do that, I have to do some other method to say if I want only the first 5 and the last 5, then I probably have to use I probably have to use take first or first and some group and last and some group. So that's important to note on take range. Back to a common issue from lots of code reviews. It's count all. And so this is a situation, again, another pattern that we see all the time is we do some kind of LINQ operation, and I want to know whether or not I got results. And so we'll do employees dot count, and we can put our filter, or sometimes we'll see up here, we'll see employees dot where and our condition, and then in my then our filter, then in our condition I'll see employees dot count greater than 0. And this works. It works just fine. And again, depending on your provider, it may be optimized pretty well. I know the .NET team has worked hard to optimize count to the extent they can, but you run a very easy risk of enumerating the full collection in order to find out whether there is something in that collection or not. So the correct way to do this is to use the short circuiting operators. So in this case, instead of doing count, I just, if all I want to know is, does this exist? Does at least one exist in my database or in my collection? I'm going to do any. And so this will short circuit. The first time it finds a Jones, it will say that it found a Jones. And there's again a complement that says if I need to find out, I mean, we're used to doing any, but a lot of people don't know that there's an all complement to any, and that says, do I need to know if all of the values are the same? So we will we'll do, for example, do all of my names start with J. So in this case, I've done a where to only get actually, I need to comment this. I've done a where to get only names that start with J, and then I'm going to do a test. Do all of the people that start with J work in engineering? And if they do, then I'm going to return everybody's in engineering. And in that case, my set says, okay, well, here's everybody whose name starts with J, but no, they don't all work in engineering. So all short circuits the first time it finds anybody that's not in engineering. But I can do a similar thing. I can do all these names contain an N. And so in this case, I've concatenated the first and last name, and it turns out that every one of these names does contain an N. So these are trivial examples, but you can imagine a situation where you can use all to do filters to make sure that your code is doing what you want it to do. I'm going to move some windows here. We're getting very close to the end. So the next improvement that we want to talk about is try get non-enumerated count. which is a really long name, but that's the name of the extension method. Try get non-enumerated count. So this is an improvement on the code that we just saw. So the typical way to count elements in an enumerable is through the count method. This does some optimizations, but you run the risk of enumerating the whole collection. So the try get non-enumerated count will first see if the enumerable can be cast to an I collection, which has even further optimized count methods. If that's the case, it can return count immediately, and we don't need to iterate over all the elements. If not, count will have to loop through all the elements, and it will report to you that that's the try get non-enumerated count will tell you whether or not you can get a count without enumerating the list. So here we have a couple of examples. First, we have just a simple array, and an array is by an array by default has a countable value that can be found. And then we have a check to our albums collection again. So we'll run each of these, and you'll see. Make this a little bit larger so you can see. So our try get non-enumerated count, you pass in an out variable that becomes available later. Can we count this? And it says true. We can count without enumerating the list, and the number of elements is 100 because I just passed in a range. How about albums? Can I count the albums without enumerating the list? And that is false. I can't count all the albums without enumerating the list. It cannot be directly cast without evaluation into a collection object or an object that has an immediately available count. So now I need to evaluate as a designer whether or not I really want to use this method to figure out how many objects I have in my list. Is that even important? Or whether I need to really go back to avoiding that using other methods to determine whether I have a match in my collection. And now we have our final example for an addition to LINQ in .NET 6, and that is the zip method. So LINQ had in older versions an ability to do zips. And zips are basically take two collections of the same size, zip them into a tuple of two elements, and then return that. So in the old days, we could take our first two lists. We could take our list of numbers and our list of months, and we could zip those together into a new structure, a value tuple. It's an interesting example to me. I've never had an opportunity where I've needed to use zipping, but if somebody has, I'm about to be done, and you can chime in when we're done here. But in the old days, the only way you could get, if you had a third value, the only way you could do that was to chain zip methods. So if I wanted to combine these three sets, sorry, let me run that again. I would get the first set, the tuple from the first set zipped with the value of the second set. So it ends up being a hierarchical set of tuples. And I could chain over and over and over. I mean, you could make this hierarchical zip as many elements deep as you wanted. Doesn't seem particularly useful to me in this structure, but they've added the ability to zip now triple lists. And so this is essentially flatten three lists into one list with three elements. And so now I have a tuple. I've got my index, I've got my month, and I've got my temperature listed in a single tuple data structure, which is interesting. I can see how this could be useful in certain situations. I've never personally had to use it, but it's also important to note that zip only supports, in this kind of flattening, three collections. You can't add if you try to zip a fourth collection like this, it will throw an error. So if I don't know, if I had wind speed or something that I wanted to zip, it will only flatten three. The fourth I would have to chain in the same way I did in the chained example. And so I would have each of these and then hierarchical to the last element zipped. And that brings us to the end of the features that were added to LINQ in .NET 6. So there's a couple of things in the last resource that I did want to highlight. So a couple of things that we didn't talk about much other than kind of in passing. And one is deferred operators versus or lazy operators versus immediate and greedy operators. And this again gets to, when is my list going to be enumerated? When am I going to have to spend the processing to go all the way through the entire list? If you're doing a lot of LINQ, it's important to understand deferred or immediate operators. So there's a research here, and I'll go ahead and post this to the chat as well. Oh, actually, I didn't. I started. So there's the. Let's see. Did that? Oh, I need to go. Here we go. Let's try this again. Everyone in the meeting. So it's a little bit harder to run the chat when you're presenting than it is when you're hosting, I've discovered. So there's the offset and fetch link for chunking using SQL Server. And most Oracle, MySQL, they all support some version of chunking on the server side. There are lots of great links on the net for understanding deferred and immediate execution. This is one that I particularly like. And then we didn't really talk much about performance improvements, and that's largely because in a talk where I'm talking about the actual features that were in .NET 6, there's no way I can do justice to the performance improvements that came in .NET 7. This link, performance improvements in .NET 7, actually covers all of what came out in the .NET 7 CLR, the framework, and not just what is in LINQ. There are a ton. Performance was the main focus for the .NET 7 release, and so I encourage you to go ahead and check that out. Click through to that link and enjoy. That can't be executed. We got to run it like this, and go ahead and enjoy learning about all of the performance improvements in .NET 7 that we couldn't cover today. You have to hurry because, like I said, .NET 8 preview is, if it's not out, it's going to be out soon. I know they already have documentation for the .NET 8 preview. So, and with that is the end of the presentation. I'm willing to take any additional questions if people have them. Oh, Alex has got a hand up, I think. Or is that applause? Hopefully that was I don't know if that's applause or a hand up. Sorry, I couldn't hear you, Alex.
Oh, that was supposed to be applause.
Oh, well, excellent. Well, thank you very much. All right. Let's see. So if there are no questions, I mean, I'll be around for a little while after the rest of the finalization of the meeting, but so I'm willing to take questions later. But thanks for letting me present this. It was a great opportunity for me. I got to learn a couple of new features. Particularly diving into the set by operations was one thing that I was surprised by. And again, I knew about chunk when it first came out. That was the feature that was in the preview that I was the most excited about. So thank you. I appreciate having